Hello, everyone. Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Okay, so in today's class, we will discuss the mock. Okay, so I'm sharing my screen. My screen is visible, right? Okay. So have you all tried solving the mock paper? Have you solved it or not? Yes, no, something. No one has tried it.
No, ma'am.
Okay, you should have tried it at least. Okay, then we will solve it. So the first question is, let x be a discrete random variable having the following probability mass function. So the PMF is given to you. Now the question is, where x is taking the value 0, 1, 2, 0, 1, and 2, find the value of k. So uh, so how will you solve this question? So we have to find the value of k here and the PMF is given. So what can we do here for calculating the value of k? Any guesses?
Ma'am, by putting X value.
Okay, by putting x value then.
By putting x
Then
value, x equal to 1, x equal to 0, probability of x plus probability of 0 plus probability of 1 plus probability of 2 equal to 1.
Yes, correct. So here what we have to do is we have to use the property of PMF. Okay. So we know that summation of all the probabilities should be equal to 1 over the support or range of x. So here we can see that x is taking three values, 0, 1, and 2. So if we take the summation of probabilities for all these three values, then it should be equal to 1. Okay, so the PMF is given, it is k times 3cx divided by 3c 3 minus x. So here x is going from 0 and going up to 2. And the PMF is k times 3cx divided by 3c 3 minus x. And this summation should be equal to 0 according to the property of PMF. Okay. Now we will put the value of x here. So it is k. Then we have 3c0 divided by 3c 3 minus 0. So it will be 3. Then we have k 3c1 divided by 3c. So 3 minus 1 will be 2. Then we have k times 3c2 divided by, it will be 3c, 3 minus 2 will be 1. So this should be equal to 1. From here we can take k as common. So 3c0 will be 1. 3c3 will also be 1. Okay. What is the value of 3c1?
6.
3.
It is 3.
3.
And what is the value of 3c2?
3.
3.
3. Okay. Then here it also it will be 3 divided by 3 equal to 1. So this k, so this is 1 plus 1 plus 1. So from here we can say that the value of k will be 1 upon 3. Okay. So 1 upon 3, which means it will be 0.33. So in this way, you can calculate the value of k. Is this question clear?
Yes, ma'am.
Okay, now see the next question. So here, which of the following variables is a numerical? So first is height. So height is a numerical variable or categorical?
Numerical, ma'am.
Numerical, right? We can measure it.
Numerical.
Yeah, it's numerical. Then we have Aadhaar card number. So Aadhaar card number is numerical or categorical?
Categorical, ma'am.
Categorical.
Categorical.
Yeah, so it will be categorical. Although we use numbers in Aadhaar card, but it doesn't have any mathematical meaning. Okay, it is just for categorizing the people. Okay. Similarly for PAN card also. PAN card will also be categorical variable,
Yes, ma'am.
right?
Yes, ma'am.
And same goes for passenger name reservation PNR number.
Categorical.
Yes, ma'am.
It will also be categorical.
Categorical.
Then we have stopwatch time.
A continuous variable.
Numerical.
Numerical. ma'am.
Numerical.
Yeah, so stopwatch time. So time is a numerical variable. Okay. Then we have PIN code. So PIN code is
Categorical.
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 Yeah. So here height and stopwatch time, these two are our numerical variables. Okay. And the others are categorical variables. Okay, then we have the third question. So the variance of a binomial random variable x is plotted against varying values of p with n kept constant. It is observed that the maximum value of variance is 40. Then what is the value of n? So first of all, what is the, here we can say that x is following binomial distribution. So what is the variance of binomial?
NP
So
minus B.
NP 1 minus
P.
yeah, so x is following binomial distribution with parameters n and p. So variance of x,
1 minus
it is np 1 minus p. And the variance, the maximum value of the variance is 40. Okay. So maximum variance, it is given as 40. Now what should be the value of n in that case? So we have to calculate the value of n, and value of p is something that is unknown to us. So how will you solve this question? And here it is given that this variance is maximum variance. So can you tell me when the variance is maximum, in which case?
When the value
when p
half
is
and
equal
P
to half.
half. Yes.
0.5.
Probability.
Yes.
when P is when symmetric.
Okay. So if p is equals to 1 by 2 or half, okay, then the variance is maximum, right? So now in this formula, we can put the value of p. Okay. So np 1 minus p, this is equals to 40. Now we have to put p is equals to 1 by 2 because this 40 is the maximum variance. So here n into 1 by 2. 1 minus 1 by 2 will also be 1 by 2. This is equals to 40. So from here, value of n will be 40 into 4. So this will be 160. Okay, is this clear to everyone?
Yes, ma'am. I want to
Yes,
ask the question
ma'am.
here. Ma'am, if like here we have taken if P is half and then variance is maximum for binomial. Is it true for the other distributions also?
No, it is for binomial distribution, not for all the distributions.
Okay, thank you.
Yeah, because here you can see the formula of variance is np 1 minus p. So basically what we have to do, we don't know the value of n. This is something we can say something about this on the basis of value of p. So if you put 1 by 2 into 1 by 2, so p is 1 by 2, 1 minus p will also be 1 by 2. So this will be 1 by 4. When you multiply it by n, that will be the maximum. If you take any other value of p, suppose n is here taking as n, and P you are taking, suppose 1 by 3. So 1 minus P will be 4 by 3. And then you have to multiply n into 4 by 3. Now you can see that n by 4 is greater than 4n by 3. So this value, the value of P, which is 1 by 2, will always give you the maximum of variance.
Ma'am, here 4 by 3, I think it should be 2 by 3, no?
Yeah, sorry. It will be 2 by 3, okay? So this value will be greater than this one, okay? So you can take any other value of P and check. So you will, when you check, then you will see that for 1 by 2 only, it is the maximum.
Yes,
Okay.
ma'am. Thank you.
Okay, then we can move on to the next question. Yes, so the next question is, if the median of the data set xi, where I is going from 1, 2, 3 up to n, is 15. What is the median of the data set to xi minus 2? I is again 1 to n. So how will you solve it?
You can just put 15 in x.
Yes. So here
20.
the value of median is 15. So in the first case, you can see that we have n observation. And in the second case also, we have n observation. And median is something that depends on the position of the data set. Okay, it's a positional measure. Okay, so this 15 is the median of the first data set. Now what we are doing, we are changing this thing. We are multiplying by 2 and then we subtracting 2. So it will simply be our old median, we can say that old median is 15. New median will be 2 into 15 minus 2. So 30 minus 2, which will be 28. Okay, so this is how you can calculate the median here. Is this clear?
Yes, ma'am.
Okay. Now the next question is, an entrepreneur has invested in 4 startups. If the startup makes profit, it will yield respective profits of 20, 25, 30, and 40 in units of lakh. On the other hand, for each startup, the entrepreneur may not gain profit. He will incur a loss of 10 lakhs. So if the probabilities that the entrepreneur will make profits from these startups are 0.1, 0.3, 0.2, and 0.1 respectively, what is the expected total profit? And a negative profit indicates loss. So we have to calculate the total profit. And the profits for profits and loss for 4 different startups are given here. So how can we solve this question?
Ma'am, we should calculate the overall profit from each startup. We have to take first a startup and the success probability multiplied by whatever profit. And then we have to subtract the loss probability multiplied 10, as 10 is given as a loss profit.
Yeah, correct. So in this way, we can calculate the profit for each different startup. And then ultimately, we have to add it to get the expected total profit. So we have to calculate the expected value of profit for each different startup, each of the 4 startup. Then at the end, we will add it. That will give us the expected total profit. So for startup 1, okay, so the profit is given as 20 rupees and the probability is 0.1. Okay, so it is in lakhs, so we can take it as 20 only, okay, because all the values in lakhs. So this is 20 with probability 0.1.
Ma'am, can you explain the question, please?
Yeah, sure. So here the question says that entrepreneur has invested in 4 startups. Okay. Now for all the 4 startups, okay, these are the value of profits. So for the first startup, he is getting the profit of 20 lakhs. For the second startup, he might get the profit of 25 lakhs. Similarly for third and fourth startup. Okay, so this is the value for profit given. On the other hand, for each startup, every entrepreneur may not gain profit. So there is a chance of loss also. Then what is the loss? Loss is 10 lakhs. So ultimately, what is given to you for each startup, the value of profit with the probability and the value of
Ma'am,
loss is given.
is this loss for the overall profits?
No, this is for each startup. Okay, so for each startup, profit, and for each startup, loss is given. And loss is same for all the startups. So that's why it is written one time. And the profits are different for different startups.
Okay.
Okay, so I can write it like this. So for startup 1, profit is 20 lakhs with probability 0.1. And loss is equals to 10 lakhs. So what will be the probability for loss? So this is for 0.1 is for profit.
0.9.
So 1, yeah, so 1 minus 0.1 will be for loss. So it is 0.9. Now we have to find the expected value. So I am representing it as E1. This is the expected profit for startup 1. Okay. So you can see that it is taking 2 values. How you calculate expectation? If you have to calculate expectation of some variable, we have to consider the values of x and we have to multiply with the corresponding probability. So here we can see that it is taking 2 values. And since it is a loss, so we will take it as negative. So the first value is 20 with probability 0.1. Other value is minus 10. Okay, since it is a loss, we will take it as negative. The probability is 0.9. So this will be 2 minus 9, which is 7. So 7 lakhs is the expected profit for the startup 1.
And -7.
Yeah, sorry, it's minus 7. So actually it's the loss. Yeah, it's minus 7. So it is like the startup will have loss of 7 lakh rupees. Okay. Similarly, we will calculate for all the 4 startups. So for startup number 2, profit is 25 and the probability is 0.3. And the loss is again 10 lakhs. What will be the probability here for loss?
0.7.
0.7.
0.7. Now we can calculate the expected profit for startup 2. So it will be 25 into 0.3 minus 10 into 0.7. Okay, calculated.
And 0.5 overall.
0.5. 0.5.
Yeah, so it will be 0.5. Okay, similarly for startup 3, so here the profit is 30 with probability 0.2. And the loss is 10 lakhs. This will be 0.8. Okay, now expected value. So this is 30 into 0.2 minus 10 into 0.8. This will be -2.
-2.
Yeah. Now for startup number 4. So here profit was
40 with
40
0.1.
with probability 0.1. And the loss is again same, 10 with
0.9.
0.9. Yeah. So here E4 will be 40 into 0.1 minus 10 into 0.9.
-5.
Okay. Now we have to find the total expected profit. So we can write that total expected profit. So for calculating the total expected profit, we will add these expected values, E1, E2, E3, and E4. Okay. And these E1, E2, E3, E4 are the expected value for their respective startups. So E1 is the expected profit for startup 1, and similarly E1, E2, E3, and E4. So the values are -7, 0.5,
-13.5.
-2, and okay. So this will be -13.5 lakhs. Okay. So option number C is correct. Okay, is this question clear to everyone?
Yes, ma'am.
Anyone has any doubt? Okay. Now the next
Ma'am,
question
in
is,
the previous question, you
Hmm.
you have taken me xi as 15. Can I ask why?
In the
Median previous fourth number question.
Yeah, this is given to us. This median is given in the question 15.
So why we have taken xi as a median?
Because we have to calculate the median of the data set. See, this is something which is representing the values of the data set. So what actually we are doing, we are multiplying by 2 and then we are subtracting 2. So same thing we have to do with the value of median as well. Okay.
Okay. Yes, ma'am.
Yeah, question number 6 is, if the graph of PMF of a binomial random variable of n equals to 10 is exactly symmetric about x is equals to 5, then the value of P could be. So what can be the value of P?
0.5.
0.5.
0.5, because we have already seen this thing that if the value of P is equals to 0.5, then the graph of the PMF becomes symmetric. Okay, so here the value of P will be 0.5.
Ma'am,
Ma'am,
can you explain this?
Ma'am, cannot this value be 1 also? Like we're giving the entire probability to x equal to 5 and rest all of the elements have 0 probability. Won't we call it a symmetric?
No, it will not be symmetric in that case. See, if you plot the graph, okay, so n is equals to 10, so which means 0, 1, 2, and it is going up to 10. Okay, so when you plot the graph and the value of P is 0.5, it comes like this. Okay, and if you are taking n is equals to 10, okay, n is equals to 10, and suppose P is less than 0.5. So less than 0.5, randomly I'm taking that P is 0.3. Then it will be right skewed. Right skewed, which means the graph will be something like this. So what does it mean? That here, suppose this is, if it is 1, this point is 1, then 2, then 3, and then going up to 10. So this, like here the probability is less, then it is increasing. Okay, it is increasing up to this point, and then it starts decreasing. So if you calculate the probability at the different points, suppose for x equals to 1, for x equals to 2, then you can verify this thing. The probability for x equals to 2 will be greater than for x equals to 1. If you're taking n equals to 10 and p is less than 0.5. Similarly, you can check if you take the value of p as 0.5, then you will get these kind of probabilities. Okay, in starting it will be increasing, then it will decrease. Okay.
Yes.
Similarly, if you want p is greater than 0.5, okay, if p is greater than 0.5, then the graph becomes left skewed. In that case, it will be like that.
Ma'am, how are you making the graph?
So graph you can make. So suppose we have n equals to 10. N is equals to 10, which means, and it is a binomial distribution. So x can take the values 0, 1, 2, 3 up to 10. Right? Now, you know the PMF of binomial distribution, what it is? NCx, p to the power x, and 1 minus p to the power n minus x. This is the probability mass function. So by using this, if you put n equals to 10, okay, and p equals to 0.5, okay, or you can calculate any value. So for all the three, you can like some value of p will be given to you, and you can calculate the value of probability for the different values 0, 1, 2 up to 10. Then you just have to plot these numbers. So how will you plot it? Suppose this is 0, this is 1, 2, 3, and up to 10. So what you have to do, and here some probabilities. So the probability minimum it can be 0, maximum it can be 1. So suppose this is 0.1, 0.2. In this way you can write. Okay. Now you will calculate value. Okay. And if you are taking p is equals to 0.5, when you calculate these values and you plot it, it will come something like this. So probability of x equals to 1 will be something here, 2 will be here, 3 here. Okay. In this way it will increase, and then gradually it will decrease. Okay, so then this is how the graph becomes symmetric like this.
And
Okay.
ma'am, is it for sure, can we say that probability of, value at 1 is same as value at, value at 0 is same as value at 10? Will it work like that?
Yes, it will be same.
Okay, ma'am. Yes.
Okay, similarly, you can plot for the other values also. You just have to calculate these value of probabilities. You know the value of n, you know the value of p, so you can calculate it. And then you just have to plot the graph as usually we draw. Okay.
So how are we using the graph to solve this question?
We are in the question, it is asked that if the graph of the PMF of a binomial random variable of n is equals to 10 is symmetric. So if the value of p, if you have seen the lectures, it is already told that if p is less than 0.5, okay, then the graph will be right skewed. Okay, if p is equals to 0.5, then it is symmetric. And if p is greater than 0.5, then it is left skewed. So when you plot the graph, then you will see this kind of graph, bell-shaped curve. So symmetric, which means if you take the middle point of this graph, here it is 50% region, and here it is 50%. Okay, this tells you the property of symmetricity.
Okay.
If you take here in this graph, suppose this is the middle point, then you know that this region has higher probability than this one, right? This area is bigger than this one, right? In this is suppose the middle point, then this area is larger than this one. But here, it is symmetric. So this portion is same as this portion. This is called the symmetricity.
Okay.
Okay,
So
so when
we
you
can
plot,
so we can say that if n is given till 10, then will be symmetric at 0.5. Can
yeah,
we
for
see?
P is equals to 0.5, the shape of the PMF is symmetric always. Also, when you increase the value of n, okay, then also it becomes symmetric. Okay, for larger n. Now is this clear?
Is there any word to address the symmetry, like where you address as left skewed? For the symmetry, is there any other alternative word to describe it?
Sorry, I don't understand. What's the question?
I mean, you actually discuss about the left skewed and the right skewed, where we are talking about the P less that. So for the symmetry, is there any other word to describe it, or it's just symmetry?
Yeah, it is symmetric.
Okay.
Like you want any synonym for symmetric?
Yeah. Any other word to describe it? Because symmetry is something where we have equal distribution. That's fine. Because when you talk about right skewed and left skewed, I was wondering, is there any other alternative word for symmetric to describe it?
No, as of now, I don't have any other word.
Okay.
Like these are the standard terms that we use in statistics.
Okay. Thank you.
Ma'am, in question 2 values are given 10 and 5. So how you have find the middle point at 0.5?
Middle point at
0.5. How you get 0.5?
this 0.5 is the probability of success.
How to calculate 0.5 from that data?
See, this is, you don't have to calculate here. This is like property of binomial distribution. Okay, so that you can remember.
Can you take a different questions with different values so I can understand properly?
Okay, so the same thing I have told you. If you want to see why it is true, you can take any value. You just take n is equals to 10, p is equals to 0.5, okay? Or in this question, n is given as 10, okay? So what you have to do here, you have to find the probability mass function. You calculate it for all the values of n, for all the values of x. So x is 0, 1, 2 up to 10. Now you have to use the probability mass function, okay? And calculate all the values of probability here. And then you plot it. Okay, then you will see that it is symmetric. You can check it for any other value of p also. You take n is equals to 10, p is equals to 0.2. Then again you find the PMF table.
But
Okay.
in question it is given the value of x, not p.
That you don't need to worry about. It is given that it is, see, n is equals to 10, then 5 will be the middle point, right? So this is the point where it can be symmetric. Okay. Like here, it will be maximum. If this is
I
0,
want to know that how you get 0.5 from this 10 and 5. Like if it is given n equals to 20 and x equals to something 10, then what is the value of p?
if n is equals to 10, oh, sorry, n is equals to 10, 20, okay,
X equals
then
to 10.
also, okay, and you are taking p is equals to 0.5. So it will be symmetric only in this case only, when p is equals to 0.5. This is the result or the property of binomial distribution. Okay, then at some point of x, it will be 10, I guess, or 11 maybe, between 10 or 11. Okay, then for that point, it will be symmetric. So if you want the graph of PMF to be symmetric, P will always be 0.5. Or what you have to do in that case, otherwise, like n should be greater than 30. Like for large sample. So in general, we say that large sample, which means it should be greater than 30. Then also, it will be symmetric. But here it is given that n is equals to 10, which means we have a small sample. So the value of P, if it is 0.5, then only it can be symmetric.
Okay, then in any case, it will be symmetric at 0.5 only.
Yeah, for P is equals to 0.5. Okay, not n, it is P which is 0.5.
Okay, then it will be only 0.5 for symmetric case. No
Yeah,
other
for
value.
symmetricity, yeah, for P is equals to 0.5 only it will be symmetric. If n is a small value. Small, which means we take in general n is less than 30.
Okay.
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 Anyone else has any doubt in this question?
No, ma'am.
Okay.
No, ma'am.
Yeah. Okay, so the 7th question is, a robber who needs to open a lock of a house has 21 keys, out of which only one key can unlock the house. The chance of selecting a key is equally likely for all the keys. The robber will not use key that did not open the lock in the upcoming trials. Let X be defined as the number of trials robber requires to open the house. What is the value of expectation of X? So how will you solve this question?
Wrong uniform distribution.
Yeah, so it will be following the uniform distribution. So here the robber has 21 keys. Okay. And the chance of selecting a key is equally likely. So X is defined as the number of trials robber requires. So we can write that X is a random variable which is representing number of trials required to unlock yeah. So how many number of trials we have in total?
21.
21, because we have 21 different keys, so we have 21 trials. Okay, we can try with each key one time. So we can say that X is taking values 1, 2, 3 up to 21, and all are equally likely, right? So we can say that like all of them are having same probability. We can write it like this: the PMF of X will be this, and the probability, what will be the probability?
1 by
1
21.
by 21.
Yes, it will be 1 by 21 for all the values, because they are equally likely. So they all will have the same probability. Okay, now here X is following uniform distribution, right? We can write that X is following uniform. It is a discrete uniform distribution taking values 1, 2 up to 21. Now what we have to find here, we have to find the expected value of X. So if X is following uniform distribution with these values, what can be the expected value of X?
21 plus 1 by 2.
Yeah, so if you remember the formula, you can just directly calculate. Otherwise, if you don't remember the formula, just use the general formula for expectation. Okay, so the values are 1 with probability 1 by 21, 2 probability 1 by 21, up to 21 into 1 upon 21. So 1 upon 21 is common, then 1 plus 2 up to 21. So this summation will be n plus 1 upon 2. So this is 21 plus 1 upon 2. So 22 by 2, which is equals to 11. Okay. Is this question clear to everyone?
Can we directly use this formula? Acceptation will be. If we know the n, we can directly put 1 by n into 1 plus n plus 1 by 2.
Yeah,
And
so
from that n,
expectation formula for discrete uniform distribution is n plus 1 upon 2. And n here is 21, right? So you can directly calculate 21 plus 1 upon 2, which will be equal to 11. If you don't remember, then you can use the PMF table, this table. And then you can calculate by using the formula of expectation, which is in general. This is the general
Ma'am,
formula for expectation.
X here
Yes.
is the number of trials required to unlock, or is it the number of the key?
Okay, these both are the same thing here. So we have 21 keys. You have to unlock 20, you have to open a lock. You have 21 different keys. So how many trials you can have? It is written that the robber, okay, this is written that the robber will not use the key that did not open the lock in the upcoming trials. So suppose if you are using one key, which is unable to open the lock, then you will not use that key again. So each key is being used for one time. So you have 21 different keys. So you can try all the keys at least one time, like one time only.
Ma'am, I was thinking it's like in the first trial I get the right key, and the second means firstly I didn't get the right key, and the second round I get the right key. Is it like that?
Sorry, can you come again?
Ma'am, I was thinking that X represent the number of keys I have tried. Like for the first X is equal to 1 means I get the right key in the first attempt only. And X is equal to 2 means firstly I didn't get the right key, means I get the wrong key, and in second attempt I get the right key.
Yeah, that's how you have to do this experiment.
Ma'am, but then
That is
X is
correct.
equal to 1, it will be 1 by 21, and X is equal to 2 will be 20 by 21 into 1 by 20.
No, but this is without replacement, right? Random selection without replacement.
Yes, yes. So the key that you have used, that you will not use again.
Yes, ma'am. So firstly, if X is equal to 2, then for me it is like 20 upon 21 into 1 upon 20. Because
Yeah,
firstly I get the wrong key and
yeah.
then the right key.
And it will cancel out, it will ultimately become 1 by 21 only.
Ma'am, I didn't get how to do this.
See, you are talking about the probabilities.
Yeah.
Yes,
Okay,
ma'am.
but here we are not calculating the probability here. We are interested in the expected value of X. Okay, so X is representing number of trials. So number of trials is like the number of keys that you have. It is similar to that.
Yeah, ma'am. It's cancel out and we get 1 by 21 directly.
It is so difficult to find that which type of distribution given in the question. How can we find it which type of distribution and given in the question?
For that, you have to understand each distribution clearly. What is the property, when, in what kind of cases it is being used, and for what kind of variable it is defined, for discrete or continuous. So here in this question, you can see this thing that you have 21 different keys. And X is representing number of trials. So number of trials, which means it is a discrete distribution, right? First of all, it is a discrete random variable. Okay. Next is that it is given that chance of selecting a key is equally likely. So in uniform distribution, all the values are equally likely, which means every value has same probability. So here you can see that X is taking 1, 2, 3 up to 21. So all these values 1, 2, 3 will have the same probability. So for having the same probability, the probability should be 1 by 21 here. And this kind of distribution is uniform distribution, where all the values are equally likely or having the same probability. Is this clear now?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, now solve the next question. John parked his car among 10 cars in a row in a mall parking, not at either end, which has a capacity of 11 cars. In how many ways is it possible that on his return from the mall, he finds that exactly 5, including his car, of the 11 places are still occupied, if both neighboring parking plots around his car are empty? So how will you proceed this question?
I think in this we can
You
take
cannot talk about 1 and
3
11
as a
first of
block.
all.
Sorry, 1 or 11? What?
I mean, he cannot take question 1 or 11, right?
Yes. So the condition is, so you have this row.
Ma'am, is the spot of the car for the person is fixed here? We are considering it fixed.
Oh, let me explain. So we have 11 places, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is one end and this is the another end. So here, that person will not be parking his car. Okay, this is the first condition given. So John parked his car among the 10 cars in a row, okay, in a mall parking, and not at the either end. Okay, so he's not parking his car at the ends of the row. And the capacity is 11 cars. Okay, so total, the parking has capacity of 11 cars, and John cannot park the car this side and this side, both the ends. Then it is given, in how many ways it is possible that on his return from the mall, he finds that exactly 5. So when he is coming back, 5 cars are there in the parking. So out of the 5 car, 1 car belongs to him. 1 is his car. And then it is given that if both the neighboring parking slots around his car are empty, which means, suppose
That he
he
cannot.
parks the car here, then this place and this place will be empty, the neighboring slots. Or suppose he is parking his car here, then these 2 places will be empty. Okay, this is the second condition. So he cannot park his car at this end and this end. Okay, so he can park his car here or here or in these positions, right? So there will be a left side or right side in both the cases. So what the second condition says that the neighboring, both neighboring parking slots around his car are empty. Okay, so both left and right side are empty. So if he is parking the car here, okay, then these 2 slots, okay, these 2 will be empty. Now, is this condition is clear to everyone?
Yes, ma'am.
Okay, so now what we have to do? So when he is coming back, he is getting 5 cars parked here in total. So what we have to do actually, so we have in total 11 slots. Suppose he has parked his car here. So these 2 slots will be empty. Now how many slots we are left with? 11 minus 3?
Yes, ma'am. 9.
It will be 8.
8 slots.
So we are left with 8 slots. Now this one belongs to John. This car is John's car. Now we have to fill these positions by the remaining 4 cars. So in total we have 5 cars, but 1 is John's car. So we have 4 cars which we have to fill in the remaining 8 places. So how can we do? So actually what we have to do, we have to select 4 out of the 8. So the answer will be 8C4. And it
But
will
ma'am,
not
here in this 8 choose 4 answer is 70. I get it. But in this case, if a car could be moved to other locations as well, as there are 9 slots and he could park in the 9. As per the description in the question, it should be 8 choose 4 multiplication of 9 factorial, because this spot can change, right? He could choose
Yeah,
anywhere
this can change.
among these slots.
Yeah, position of John's car can be changed. That is okay.
So I think ma'am 9C4 will come. No?
Yeah. So it will
Then
be
why are we
9C4.
not including the 9 factorial here, as he could choose
Uh,
other spots as well, and then the scenario will change.
Okay. So 9, see, the question says that in how many ways is it possible that on his return, like they have to, all the 5 places are occupied. So occupied, which means we are not worrying about this thing. So, okay. So
we are considering the John's car as a fixed point. We are not switching it here.
No, it can be moved. It can move. It can be this position or this one or anyone. Okay. Except
But in
these
that case, it
endpoints.
should be, ma'am, multiplied by 9 factorial as well, if he is allowed to switch his position.
No. Okay, let me explain this thing. In what case we can multiply 9 factorial? We just have to fill these positions. Suppose this is John's car, and then we are filling the remaining 4 cars. Suppose this is C1, C2, C3, C4, like this. So we just have to fill the position. We are not worrying about this thing, that whether this is C1, J, C2, C3 and C4. So we are not worrying this arrangement. We just have to fill the position. Okay. So we are not doing arrangement. We are doing the selection only.
Okay.
It is like, yeah. So it is like that these 2 positions, like wherever he has parked his car, this is one position, and the neighboring 2. It can be anywhere in this. Okay. So these 3 positions, we are just removing them. So now we are left with 8.
John's car doesn't change.
Position of
change
John's
position.
car can be anywhere in this. I just have taken a random position to explain you. It can be anywhere here,
So we
except the
should
endpoints.
multiply with all the cases possible, right?
That's what I explained here, that we don't need to multiply with 9 factorial. What we are doing, we are just filling the cars, filling these places with the cars. So that allocation of John's car is already included in this, actually. We are not worrying that whether this car is parked here or here. C1 is parked here or here.
So we are looking at the scenarios. He is already parked. Now we are just selecting the spot for the other cars. Simple.
Yeah, wherever he has parked, we are left with 8 positions, 8 places to be filled. In total, we have 11. So 3 places we cannot fill. Okay. This is one position, and these are the other 2 positions left and right to his car. That we cannot fill. It can be anywhere here. So we are just removing these 3 places. So now we are left with total 8 places. So that we have to fill the remaining 4 cars. Because this we have already filled. So this John's car, we don't have to consider here. Now we just have to fill the remaining 4 cars. Okay. Now are you able to understand this thing?
Yes, ma'am. Yes.
John's car can park in one choose one way.
John has these 9 places to be filled. So it can be 9C1, yeah, 9.
Then 9 will also be multiplied now.
see, that scenario is actually already included here. So maybe the thing is, because of the framing of the question, you are getting confused, but this is how we have to solve it. Can you please mute your mic, whoever it is? Yes. Okay, yeah, this is how we have to solve the question. It's the correct method.
And what about the places where John will park his car? Like we haven't considered that which place he will park his car. We are just saying that all this. I'm sorry for the backup. Like we are just omitting 3 out of 11, and we are doing combination with the rest.
Okay, I'll see this question. Maybe we can reframe the question properly, then I think it would be clear. But at this point, I will say that this is the method we can solve it. Okay, I will see this question later. Okay. Now, should we move on to the next one? Yes, no?
Yeah.
Yes, ma'am.
Okay. Okay, so the next question is, two players, Sam and Nina, throw a pair of dice alternatively and independently. Sam wins if he throws a sum of 6 points before Nina throws a sum of 7 points. While Nina wins if she throws a sum of 7 points before Sam throws a sum of 6 points. So if Nina begins the game, then what is the probability of Nina winning the game? So when Nina can win the game is, the condition is if she throws a sum of 7 points before Sam throws a sum of 6 points. Okay. So we can consider, so suppose S is something which is representing that sum is 6 points. Okay. And N is something which is representing that sum is 7 point. So if I write the set S, so sum is 6, which means it will include 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. Right? This will be the set for S. Similarly, we can write the set for N, where the sum is 7. It will be 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. Now I can write the probability of S and probability of N. So what it will be? What is the probability of S?
5 by 36.
It is 5 by 36. So since we are throwing 2 dice, so it will be a total number of outcomes will be 36 and favorable are 5 here in this set. Similarly, for N, it will be 6 by 36. If I have to write the complement of it, it will be 1 minus 5 by 36. So it will be 31 by 36. Similarly, probability of N complement will be 30 upon 36, right? Now we have to find that when can Nina win the game if she begins the game. So if Nina begins the game, then the cases in which she can win.
Ma'am,
So
here do we
maybe
need to use conditional probability?
we don't need to use conditional here. Okay, I'll solve it and you will get it. Okay. So what can be the first case? So she is beginning the game, right? So maybe she can win in the first throw itself. So the first scenario can be Nina wins the game. Nina wins the game in the first throw. Okay, and these throws are independent actually. Okay, it is given that two players, Sam and Nina, throw a pair of dice alternatively and independently. Okay, their throws are independent. So if Nina is winning the game in the first throw, what can be the probability?
50%?
Ma'am, 1 by
Probability of n. Okay, which
or
is
6 by 36.
6 by 36. We can see. So when can Nina win the game? The condition was if the sum is 7 point. Okay, then Nina will win. And that 7 point should come before the other player, Sam, gets the sum of 6 point. So if Nina is getting the sum in the first throw itself, which is 7, the sum is 7, then she will win the game. And the probability of getting the sum 7 point is 6 by 36. So this probability will simply be 6 by 36. Right? Now the other case can be, because Nina is beginning the game, so first chance is Nina. In the first, Nina will throw the die. Then in the second chance, Sam will throw the die. And then in the third chance, again Nina will throw the dice. Right? So again, Nina can win the game. The second possibility can be Nina wins the game in the third throw. Right? Is this statement clear? This can be the other possibility. Because the second chance belongs to Sam. So in second throw, she cannot win because she is the first one starting the game. Okay. So she is winning in the third throw, which means in the first throw, she will not win. So in the first throw, she is not winning, which means the sum should not be 7. Right? So sum is not 7, will be probability of n. This is n complement, right? Is it correct? If I write this event, it will be n complement in the first row. Then in the second row, Sam should not be getting the sum as 6. Because if he gets the sum 6, then he will win the game. Right?
Yes, ma'am.
Are you getting my point or not? What I'm saying?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
in the second throw, second chance, I mean, so in the second chance, Sam will not be getting the sum as 6, which means S complement. This event is represented by S complement. Okay. Now in the third throw, Nina is winning the game, which means the sum should be 7, which is represented by N. So this is the event. Now we have to calculate this probability. Is this clear to everyone? Then I will solve the next step.
Yes, ma'am.
Okay.
Ma'am, she wins in the, she has the probability of winning in the first and then the third.
Yeah.
So what will be the probability of the third chance? 6 out of 36?
Probability of
What
winning the
will be the
game in the
probability
third
of
throw.
Nina winning the game in the third throw?
Yeah, that's what we are calculating here.
Okay.
Okay, Nina is beginning the game. So she is the first one to start the game. So she has, like, in the first chance, she will throw 2 dice. Okay, then in the second chance, Sam will throw. Then in the third, Nina will throw. Then in the fourth chance, Sam again will throw. So she has the like chances first, third, 5, and all the odd numbers, right? In the odd places, she is throwing the 2 dice. So either she can win in the first throw, or she can win in the third, or in the fifth, like this. It will go like this. Okay. So now in the first case,
Ma'am, what
we
you
have,
have written, ma'am? N complement intersection.
yeah, N complement intersection S complement, because in the first row, Nina is not winning the game. And there is an and condition, right? After the first row, Sam will throw 2 dice in the second chance. And
So
he is
will this
also
go for
not winning the game.
infinity?
Yeah, it will go for infinity, but here we are taking for the third throw only. Okay, we will take all the cases. So first we have taken for the first throw, then we are taking for the third throw, then we will take all the throws. Okay. So is this statement clear? For the third throw only. It is not the final answer. Okay, I will solve it further. It is not the final answer. Okay, so all the throws are independent. Okay, so it will be probability of N complement, then probability of S complement, and then probability of N, because these throws are independent of each other. Now just put the value. What is the value of N complement? It is 30 by 36. Probability of S complement is 31 by 36. Then probability of N. So probability of N is 6 by 36. Is this clear now? Similarly, we will calculate for the next possibility, which is that Nina can win the game in the fifth throw.
Fifth row.
Okay. So Nina wins the game in the fifth throw. Okay. Now, if she is winning in the fifth throw, which means if I write this event, so which means that in the first, she is not winning, right? In the second, Sam is not winning. Then again, Nina is not winning. Again, in the fourth trial, fourth throw, Sumit is not, sorry, it's Sam. Sam is not winning. Then in the fifth one, which belongs to Nina, yeah, now she is winning the game. So it will be N. We have to calculate this probability. Okay. And all these are independent. So we can just multiply this. So N complement is 30 by 36. Yeah, this is 30 by 36, and S complement is 31 by 36. Okay, and this will be 6 by 36. Okay, these two, first, second, then third, fourth, then fifth, sixth, like this. Now we know that for all the odd places, she has chance to win. Okay, so it will go up to infinity. Now we have to calculate the final probability. So probability of Nina winning the game . So what will we will do here now?
Ma'am, we can use series and add all
Yeah,
the
that we
capability.
will do. Okay. So what we have to do? We have to add all these cases, right? So actually there is a or condition. So either she will win in the first throw, or in the third, or in the fifth. So we have to add the probabilities for all the cases. Okay. So the first one is 6 by 36. For the first case, we have 6 by 36. Okay. Then For the third throw, which is the second case, we have this probability. Okay, so this is 30 by 36 multiplied by 31 by 36 into 6 by 36. Then the next possibility is this one. Okay, so we have 30 by 36 into 31 by 36. This is coming 2 times. I can write the square of this term, right? 6 by 36. Is this correct? Okay. Now, if you calculate for the seventh throw, it will be 30 by 36 into 31 by 36 whole cube. And then 6 by 36. Is this correct?
Yes, ma'am.
Okay. Now it has become a geometric series. So first of all, we can take 6 by 36 common, right? Then it will be 1 plus 30 by 36, 31 upon 36. Then we will have square of the same. Then we will have cube and power 4 like this. Now we can see that this entire is a geometric series, infinite geometric series. What is the formula for infinite geometric series? Summation of the series?
A by 1 minus R.
Yeah, A upon 1 minus R. So A is the first term and
Yes,
R is a
ma'am.
common ratio. So here the first term is 1. So A is 1 divided by 1 minus R. R is the common ratio, which is 30 upon 36 into 31 by 36. Now you just solve it and this will give you the final answer. So this is 3 by 36.
0.59.
This will be 366. So when you solve, it will be 0.59, right? So this is the final answer. Okay, now it is, you can check that it is coming in the range. Now is this question clear to everyone?
Yes, ma'am.
Okay, then solve the next one. So here we have, suppose that the random variable x assumes 3 values, 0, 1, and 2, with probabilities 1 by 3, 1 by 6, and 1 by 2 respectively. Calculate the value of f1. So what is this capital F1?
Cumulative.
It is less than
TDF.
equal to
1 by 3 plus 1 by 6.
Yeah, so it is actually the CDF of x at point 1. Okay, so first of all, we can write the PMF which is given in the question. So x is taking values 0, 1, and 2, and the probabilities are we have to calculate F1, which means we have to calculate that probability x is less than or equal to 1, which means probability at x is equals to 0, and we have to add probability of x is equals to 1. So this is 1 by 3. This is 1 by 6. So this will be 1 by 2, right?
what, ma'am?
Yes.
Ma'am, how to identify it's a CMO?
It is CDF. Okay, first of all. So
Yes, ma'am.
yeah. So okay, so PDF is generally written as small fx, and the CDF is written as capital Fx. So if you are there is a notation of capital F that represents the CDF, And this small f is used for PDF. So here you can see that it is written the value of capital F at point 1. Okay, so we have to calculate the value of CDF at point 1. And this is defined as this. Okay, what is the formula for CDF? So CDF at some point A, suppose, it is defined as probability that X is less than or equal to A. Here, the value of A is 1. Now, is it clear?
Yes, ma'am.
Anyone else has any doubt? Otherwise, I will solve the next question.
Can you explain again? Actually, my Wi-Fi connection got lost.
Okay. So the question is, suppose that the random variable X assumes 3 values. Okay. So X is taking these 3 values with probabilities 1 by 3, 1 by 6, and 1 by 2 respectively. So we are given the PMF probability mass function of the random variable X. This I can write like this. Okay, PMF table. Now, calculate the value of capital F1. So this capital F1, what do you understand by it? What is this capital F1?
Is it the probability for getting 1?
It is not the probability for 1, it is the cumulative distribution function at point 1. So you can see it is a capital F, okay? So capital F denotes the CDF function. And if there is a small f, then it represents PDF. Okay? So capital F at point 1, which means we have to find the CDF at this point 1. And
What
this is the formula.
PDF?
PDF is probability density function, which is defined for continuous random variable. This is something we don't have to use in this particular question because here X is a discrete random variable. Okay, and this CDF is cumulative distribution function. So cumulative distribution function, which means it accumulates the probabilities. So suppose you have to find the CDF, this capital F, at some point A. So this is A. What it does is it accumulates the probabilities, which means you have to add these probabilities before up to point A. So probability that X is less than or equal to A. So this is how we define the CDF function or cumulative distribution function. Okay, and this value of A, this point is given as 1 here in the question. So what you have to do, you have to add the probability up to point 1. So before, yes?
PDF is a continuous function.
PDF is defined for continuous function, yes. Okay, just to make you understand what is the difference, because PDF is a small f and the CDF is capital F, that's why I have written here. Okay, PDF is defined for the continuous random variable. And probability mass function, or in short, PMF, this is for discrete random variables. Okay, and here in this particular question, we are using PMF that you can write in this table form. Okay, so what you have to do, probability X is less than or equal to 1. So you can see that before 1, it is taking values 0. So basically, you have to add the probabilities up to 1, which means you have 2 points, probability at point 0 and at point 1. So you just have to add these two. Now is it clear? Should we move on to the next question?
Yes, ma'am.
Okay. Okay, so 11th question. So let X follows exponential lambda, then find the value of Z such that this probability, that probability X is greater than or equal to 100, given that X is greater than or equal to 50, it is equal to probability X is greater than or equal to Z. So you just have to use the PMF of exponential, CDF of exponential distribution, or you can use the CDF directly. If you remember the formula of CDF, that you can use directly, or you just integrate the PDF for calculating these probability. So it is given. So x follows exponential with parameter lambda. What is the probability density function for exponential?
1 minus e raised to the power minus lambda x.
Lambda into e to the power minus lambda a.
Lambda e to the power minus lambda x. Okay, this is the PDF for exponential. We are given that probability x greater than or equal to 100, given that x is greater than or equal to 50, this is equal to x greater than or equal to z. So first of all, we have to write the conditional formula, right? So it will be x greater than or equal to 100, intersection x is greater than or equal to 50, divided by what? What will come in the denominator?
Probability of x greater than equal to 50.
Now what will be the intersection of these two?
Ma'am, excuse me.
Hmm.
Can we use memoryless property here?
Yes, we can use. It's good if you remember, it will save your time. But if in case you don't remember it,
What
you
is
have to-
memoryless property?
Okay. Memoryless property is that the current trial does not depend on the previous one. Okay, so the formula is defined like one minute. So it is that probability of that if you have x greater than m plus n, given that x is greater than some value m. So this probability is equal to probability of x is greater than n. Okay, so if you want to apply this here, so here x is greater than or equal to 100, given that x is greater than or equal to 50. You can write it as x is greater than or equal to 50 plus 50. Right? This 100 can be written as this 50 plus 50. Yes or no?
Yes.
Now the value of m, what is the value of m here if you compare it with this formula?
50.
It is 50. Okay. And what will be the value of n here?
50.
50. So in this particular question, it is same. So what will be this according to the memoryless property? It is x is greater than 50. Okay. So if you compare, you can see. So from here, you can see that this z should be equal to 50, right? This value. Okay, this is according to the memoryless property.
Sorry, I forgot. What does the pipe symbol denote here?
Sorry?
I forgot. What does the pipe symbol denote here? You
It's
say x is
given that.
given
This
that.
one?
Okay.
Yeah.
Yeah.
It's given that, yeah.
Thank you.
Ma'am, is it included in the syllabus?
I think it's not here in your stats one
Yeah,
course.
it was not in the
Yeah, it
lectures.
is actually in the statistics 2 course. Okay, if you study statistics 2, then you will use it. Okay, that's why I was not solving this question using this. Okay, so you can just leave this property as of now. We will use the simple method that we have studied. Okay. So, okay, so yeah, we were solving here. So what will be the intersection of these two?
Ma'am, P greater equal to 100.
Yeah, x is greater than or equal to 100. Is this clear to everyone, or should I explain it how intersection is x is greater than 100?
Yes, ma'am, it's clear because this one is greater than 50 and the other one is greater than 100, then both of them will be meeting at greater than 100.
Yeah. Okay, so this is the intersection part. Okay, now I'm solving the question here again. Okay, just leave this part. So probability x greater than or equal to 100 divided by probability x is greater than or equal to 50. And here we have probability x is greater than or equal to z. And we have to find the value of z. Okay, and here x is following exponential distribution. So if you remember the CDF of exponential distribution, so CDF of exponential distribution. So this is defined as, so if you want to find the CDF at some point A, the formula is 1 minus e to the power minus lambda A. Okay. Now I can write this term.
Ma'am, are we going to get the formula sheet in exam?
No. For stats one, you will not get the formula sheet.
Okay, ma'am.
Okay.
Now, how many
And we know
questions
that
except from center in stats?
number of questions you're asking,
Yes, sir.
you can expect it around 14 to 15 questions on an average. Yeah.
40 to 14.
14, 1/4, 14.
Okay.
It's not the exact number, but yeah, around 14, 15 you will get.
We'll
Okay,
be able
so
to solve all of these within the time if such
yeah, sure. If you have
long
good
questions.
practice, no. If you have good practice, you can solve it.
Okay.
It's from second slot, no? We can get 3 hours for that, no? CT and stat.
That is something I'm not sure.
Yes, CT and stat combined is 3 hours.
It will be different for every student. For
Okay, you
some,
can
it may
discuss
be
these
maths
things
and
later.
For us,
stats.
it will be
Okay.
same, right? For all of us, it will be same. It will not be different for all of us. It will be
No,
different
no.
for, is
It will
it?
be different for
Why so?
everyone.
Huh? Why?
So yeah, wait. You all can discuss these things later. Let me just finish all the questions, then we can discuss. Okay. So this term I can write
Sure.
like this: 1 minus of this probability.
Yes, ma'am.
Okay. Now I can use. Now this is what? This is the CDF of x at point 100. I can write like this. Will it be correct? And this one, I can write 1 minus probability x is less than z. And since it is a uniform, it is a continuous variable. So if you write x is less than 100, or if you write x is less than or equal to 100, that will not make any difference, because the probability at particular point is 0 for a continuous random variable. Okay. Now we can just put the value of the CDF. So it will be 1 minus e to the power minus
Lambda.
lambda
Lambda.
a. So this is lambda. What is the value of a here?
100.
100. Okay, this is 100. Here it will be 1 minus e to the power minus lambda into 50. And here it will be 1 minus e to the power minus, what will be?
Minus lambda z.
Lambda z. Okay. So this one will be cancelled out. It will be minus 100 lambda divided by okay, it will be e to the power minus 50 lambda, and here it is e to the power minus z lambda. Now you can compare these two. So the value of z will be equal to 50. Okay. Is this question clear to everyone?
Yes.
Yes, ma'am.
And if you don't remember the formula of CDF, then you have to integrate the PDF. In that case, you can use the PDF of, you can use this PDF of exponential and just put the value, okay, to integrate these probabilities. You have to integrate the PDF.
Now from this formula, it's take time, I think. If we can use memory less, so it's time saving.
Sorry, what?
I mean, if we use this method, which take
We all don't
time.
know memory less yet.
You can just leave this thing, okay? It's not in your syllabus in the stats.
He's saying that it will save time if we use memory less
Yes,
property,
yes.
but
Yeah,
we
it
all
will
of
save
us
you.
do not know what how to do this. So
Yeah. Yes.
And ma'am, this memoryless is true only for like right now exponential or for every other kind of distribution?
Not for all the distribution, it is for exponential and also for geometric.
Ma'am, you mean hypergeometric because geometric is not for us?
No. It is for geometric distribution, not for hypergeometric.
So
we
for
don't
us,
have geometric, ma'am.
so for
We
us
don't have
only,
geometric in our syllabus.
No.
no. So for us only exponential, then we can apply.
Yes.
And it's just like ma'am finding the difference between the two values.
Yeah, this is the formula. Now you can accordingly fit the values. Suppose if it is 150, if it is probability x greater than 150, given that x is greater than 50, then this 150 you can write 100 plus 50. Okay, then it will be x greater than 100. Okay. So you have to remember this thing, and accordingly you can adjust your values. Okay.
Okay, ma'am.
Do we have normal distribution in our syllabus?
You have in your syllabus, but it is not coming in your end-term exam. So for end-term exam syllabus, it's not coming.
Okay.
Ma'am, will we repeat this normal distribution in stats too? Because I have not studied it at all because it's not coming in the exam.
Yes, it will. It's actually a very important distribution.
Yeah, that's what I'm asking. It is important and for stats too, but I'm not studying it at all right now.
So
Wait,
for
it is not
end-term
coming in exam?
normal distribution will not come in the end-term exam. It will not come, but for statistics 2 course, you have to study it. So
So
for
for
the
in the stats too, there
for
will
the
be repetition of normal or not?
yes, it will be there.
Or will we have access to the this portal right now that we have stats 1? Will we have access to this if we want to go back and study?
I don't think so. You will have the access of the portal,
Okay.
but you will study there, so don't worry about that. It will be discussed
Okay,
there.
fine then. Okay, thank you.
Okay, then now we can solve the next question. Is this clear to everyone?
Yes, ma'am.
Okay, the next question is, according to a survey, the time taken by teenagers to finish a box of donuts is uniformly distributed between 1 to 6 minutes. A cafe in New Delhi used this data for the advertisement that challenges teenagers to finish a box of donuts within 100 seconds to win a grand prize. A teenager, Ajay, accepted the cafe's challenge. What is the probability that he will finish the box of donuts within 4 minutes, given that he lost the challenge? Okay, so first of all, we can assume our random variable. So x is our random variable, which is representing the time.
Here you can use conditional probability, no?
Yes, here we will use conditional. So time taken by teenager to finish a box. Okay, so it is the time taken by teenager. You can write the full form. Okay, I'm just writing in short. Now here x is following uniform distribution in this interval. Okay, 1 to 6. Now what we have to find. So the first thing is that when the person can win the challenge, it is that if the teenager finished the
If it
box of
complete-
donuts within 100 seconds. Okay. So if the timing, if the x is less than 100 seconds, then the teenager will win the prize. Okay. This is something we are given. Now the question is, we have to calculate the probability. He will finish the box of donuts within 4 minutes. So probability that this time within the 4 minutes, which means less than 4. Then given that he lost the challenge. So lost the challenge. So what is the meaning of losing the challenge here?
That he could not finish within 100 seconds.
X greater than 100.
Yeah, x greater than 100 seconds. But here we are given in the minutes, so we can convert it in minutes. So like all the units.
1.66.
Yeah, so x is greater than. So it will be 100 by 60 or okay. So I'm just writing in fraction. Okay. So this is something we have to calculate. So we can write that. So what will be the intersection of these two? So x is less than 4 and greater than 5 by 3 divided by x is greater than 5 by 3. Okay.
Ma'am, can you explain again how this 5 by 3?
Okay. So 100 seconds. So in 60 seconds, you have 1 minute. So in 100 seconds, how many minutes will you have? It will be 1 upon 60 into 100. So that will be 5 by 3.
1.67.
Yeah, you can take that also. Minutes, okay? So since this 1 and 6 and this 4 are in minutes, so we have to convert this 100 second in minutes. Okay, that's why I have written like this. Now just solve it. So if you remember the properties, it is equal to what? Probability x is less than 4 minus probability
P
x
minus
is less
C
than,
maximum minus minimum.
and this we can write 1 minus probability of x is less than 5 by 3. Is this clear to everyone? Now
Yes,
these terms are CDF, right? This is the CDF at 0.4. This is the CDF at 5 by 3.
Why we are subtracting probability of x less than 5 by 3 from probability of x less than 4? We have to take the intersection, I think.
Yes, this will be the intersection part. Okay.
How the intersection will become this difference?
Okay, if you remember the formula, this FB is nothing but x is less than or equal to B minus x is less than or equal to A. So this is the property. Okay, if you studied the lectures properly, you would have seen this.
Okay.
Okay. So here B is 4 and A is 5 by 3. Okay, it is given that x is less than 4 and it is greater than 5 by 3. Okay, so less than 4 and greater than this, which means it will lie in this range, right? This will be the common part.
Yes, ma'am.
Yes.
Okay. And now you can write this probability as this. Okay. And these terms are nothing but the CDF. Okay. Now it is a uniform distribution, continuous uniform distribution. If you remember the formula of CDF for continuous uniform distribution, you can just use that. So, okay, I will write the formula also here. So this is CDF. So if X is following uniform A comma B. Okay. So if X is less than A, it will be 0. If it is between A to B, the formula is X minus A divided by B minus A.
B minus A.
And if X is greater than or equal to B, it will be 1. Okay. So now you can see this 4 and the range is 1 to 6. Okay. It is defined between 1 to 6. 4 is coming between 1 to 6. Okay. So we can put the value. So here we have X less than 4 given that X greater than 5 by 3. So this is equal to this probability. Okay, I am writing from here. Okay, then we have 5 by 3. Okay, 5 by 3 minus 1 divided by 6 minus 1. 1 minus 5 by 3 minus 1 divided by 6 minus 1. Now just solve it.
7 by 20.
So it is 7 by 13. Okay. So yeah, option number C is correct. Is this clear to everyone?
Yes, ma'am.
Okay, the next question. A company has predicted that the next yes.
Well, when was this announcement made that normal distribution is not coming in it?
We have told it in the sessions, live sessions.
Other than the sessions?
It
No.
was told multiple times since the beginning.
We
It
have
was
not
told
sent the
Ma'am.
announcement, but
Ma'am,
Announcement
is
in what exactly? Like in the dashboard?
no. You will not
not
find
in
it
the
in the
dashboard.
dashboard. We have told it multiple times in the sessions. So if you have attended the previous sessions, you would know.
Ma'am, is triangular distribution is in the syllabus?
Yeah, it's in the syllabus.
That's the thing, right? Many students like me, like I was busy for college admissions. That's why I couldn't attend any session. But many students do not attend the sessions. How would they know?
See, it's not like that normal distribution is not in your course. It's there in your syllabus, but for the end term exam, it's not coming. If you don't know, you will study
I'm
this.
saying that at
Then
least
it's
it
your
should
loss.
have been like officially, like, in some announcement session, or maybe the personal event should have been notified, or maybe even at the lecture, there should have been a disclaimer that it's not coming in it.
It's not like it is fixed that it will not come. So this time it's not coming. That's why we just have told you.
Ma'am, can you
So there will
continue?
be no question in the exam. Otherwise, it's in your syllabus of the Statistics 1 course. If you
Yeah,
want, you
ma'am. I have
study
heard
that.
that normal distribution is very important for the stats too. It's good that we learn, but
Yeah, it's
yeah.
good if you learn it. Okay. The only thing is that the people find it difficult. So that's why you're just not giving the question in the end time exam. Otherwise, you have to study it. If you are studying statistics, you have to study normal distribution. Okay? It's very important thing in the statistics. Okay, now we can move on to the questions. Okay, so the next one is a company has predicted that the next year's profit will follow the probability distribution shown in the table, that the random variable X denote the profit in million rupees. Loss is denoted by a negative profit. But the company cannot retain all the profits to itself since it has to share 15% of profit to its investors. The amount that the company retains is given by y equals to 0.85x. So what is the approximate standard deviation in million of rupees of y? So how will you calculate this thing?
You can find the
Then you can directly
standard
apply variance
deviation
formula and then
of
standard
X.
deviation.
Then after that, we can multiply from 0.5, then we can find y.
Yeah, so we have to find standard deviation of y. Standard deviation, which means we have to first find the variance of y. How can we find the variance of y? It is y is actually the function of x. So actually we have to find the variance of x first. And after calculating the variance of x, you can find the value of variance of y and then standard deviation of y. How can we calculate this variance of x? This PMF table is, the PMF table is given. We have to first calculate expected value of x, then expected value of x square.
For X or for Y?
First, we will calculate for x, okay, and then by using the property, we can find the variance of y. So the relation between y and x is given, and we know the PMF of x, so we have to use it. So first, we will calculate the expected variance of x. Okay.
No, I don't understand. We are finding for X and for Y. Like for standard deviation, we are finding X for Y.
Standard deviation we have to calculate for y, but for calculating this thing, first you have to calculate variance or standard deviation of x.
Yes, ma'am, yes, ma'am. That's my answer. Yes, thank you.
Yeah, okay. Because y is dependent on x, okay? So you have to calculate for x first. So what will be the expectation of x? So this is summation of x. Okay, calculate the expected value of x.
1.15.
Okay, it is 1.15. Okay. Then we have to calculate expected value of x square. The formula is that summation of x square times probability of x taking value small x. Now calculate this thing.
2.9.
2.29.
2.29.
It should be 2.9.
Yes, ma'am.
Okay. So this value will come 2.9. Now we will calculate variance of x. Variance of x will be expected value of x square minus expected value of x whole square. So 2.9 minus 1.15 whole square.
It's 1.5775.
So we can round it to 2 decimal place. It will be 1.58. Okay. Now we have to calculate the variance of y. So y is equals to 0.85x. If you remember the property of standard deviation, so standard deviation of y will be 0.85 times standard deviation of x. Okay, otherwise just use this thing. Variance of y will be.
Ma'am, can you repeat what you said?
we know the properties, standard deviation of y will come like this. Otherwise, just go with the basics. So variance of y, what will be the variance of y?
Can we find directly standard deviation of x by square root?
Yes, which will just take the square root of it and it will give you the standard deviation of x. Okay, you can just directly solve that. But if in case you don't remember, so I am just telling you from the basics. Okay, so what will be the variance of y? So it will be variance of 0.85 times x, which means 0.85 square variance of x. So I'm just explaining how does it come. Okay,
Ma'am, how 85? Okay,
this is
okay.
given in the
Oh,
question.
wow. Okay, fine.
Okay, so now we have to calculate standard deviation. So we'll take square root at both the sides. If you take square root of 0.85, it will be this. Here we have a square and it will give you standard deviation of x, right? So 0.85 and standard deviation of x is square root of variance of x. So variance of x is 1.58. Now just solve it.
1.25.
Ma'am, 1.15, right?
I think 1.25.
Ma'am, expectation of x.
It will come like 1.06, the final answer.
Yes, ma'am. Final answer is 1.07.
Yeah, 0.6 or 0.7, so you can round it. Okay, so that's why range is given in the question. Okay, okay, this is a multiple choice, so you can see like what is the nearest option. Okay, so 1.06 will be the answer. Okay, is this clear?
Yes, ma'am.
Okay, the next question is the duration of a video game is a random variable with an exponential distribution with me 20 minutes. Suppose that when you enter a video arcade, two players are playing the game independently. For the probability that find the probability that exactly one of the two players will be playing for less than 40 minutes. So how will you solve this question?
By exponential distribution.
Yeah, that is okay, but what we have to calculate?
TDF.
Because two cases.
P of x less than 40 multiplied P of x greater than 40.
Greater than 40 or less than 40.
Yeah. So first of all, we have to calculate the probability that x is less than 40. Okay, and what is x? X is representing the duration of the video game.
40.
X is representing the duration of video game and x is following exponential distribution. What will be the value of lambda?
1 by 20.
1 by 20.
1 by 20 because the mean is 20. So mean expectation of x, which is 1 upon lambda, this is given as 20. So the value of lambda will be 1 upon 20. So this is 1 upon 20. Now, first of all, we have to calculate that the duration is less than 40. Now here we can directly use the formula of CDF.
Yes.
Right? So this is 1 minus e to the power minus lambda a. So lambda is 1 upon 20 and the point is 40 here. So this is 1 minus e to the power minus 2. If I have to calculate probability x is greater than or equal to 40, then it is 1 minus probability x is less than 40. Okay, so just put the value. So 1 minus. So this will be e to the power minus 2. Okay, just give me 2 minutes. This PDF doesn't have any more pages. Yes. So we have solved till this point. Okay. Now in the question, what is asked, that find the probability that exactly one of the two player will be playing for less than 40 minutes. So how can you solve this thing? Okay, and the playing is independent. Okay, they are playing independently.
Ma'am, one person plays less than 40, another does not play. And then we have to do it for the same again.
2 into less than and greater.
So if I consider an event E1, okay, so which represents okay, so this is representing that player. So we are calculating that. So he's playing for less than 40 minutes. Okay, so what we have to calculate, the required probability is probability that exactly one player, one of the two will be playing for less than 40 minutes. So this is something we have to calculate. So this will be equal to probability of E1. So I can write this. So this is for player 1 and this is for player 2. So exactly 1, which means if even like if the first player is playing for less than 40 minutes, then the another player will not be playing for less than 40 minutes, right? So it
Yes,
is
ma'am.
E2 complement. Or we can write that E1 complement into E2, which means that player 1 is not playing for less than 40 minutes and player 2 is playing for less than 40 minutes. Okay. Now this is something we have calculated. Playing less than 40 minutes. It is what we have calculated it as 1 minus e to the power minus 2, right?
Yes, ma'am.
So this will be 1 minus e to the power minus 2. And what is for if not less than, which means greater than, it is e to the power minus 2. Is this thing clear to everyone?
Ma'am,
Just
can you
add
say
it.
it again? From E2, can you say that again?
Yeah. So E1 is representing that player 1 is playing for less than 40 minutes. Okay. And E2 is representing that player 2 is playing for less than 40 minutes. we have to find the probability that exactly one of the two will be playing for less than 40 minutes. So player 1 is playing for less than 40. So which means here we have x is less than 40, and here we have x is greater than or equal to 40. Here we have x is greater than or equal to 40, and x is less than 40. So because we have two players, so maybe player number 1 is playing less than 40 minutes, or player number 2 is playing less than 40 minutes. So two scenarios can be there, right?
Yeah.
This is for player 1 and this is for player 2.
Yeah. Okay.
Okay, so we just have to add these. And this is something we have already calculated here. Okay, so this is our answer. So we can check that option number B or 2.
Yeah,
Okay,
how 2 multiply? I don't understand that.
2, you have to add it. We have two terms, right?
Okay.
Okay, now the 15th question.
Ma'am, could you
fruit
just show the page again? Yeah, okay.
Okay, a fruit seller has 6 dozen bananas, out of which 12 are rotted. If a customer wants to purchase some bananas and chooses 6 bananas without replacement, then how many rotten bananas can expect customers? So what will be the distribution here?
Hypergeometric.
Hypergeometric, because we are doing the selection of items without replacing them, without replacement. Okay, so I can write so in total we have 6 dozen, which means 72, right? 6 into 12.
Yes, ma'am.
Yes,
Okay,
ma'am.
in total we have 72, out of which 12 are rotted. So out of which 12 are rotted. So remaining 72 minus 12, which is 60, will be non-rotted. Okay. Now we are selecting. The customer wants to purchase 6 bananas. Okay. So how many rotted bananas can we expect? This is something which is asked. So if I take the random variable x, which is representing number of rotted bananas, okay. Now since it is following hypergeometric, so we have to find these 3 values. What is the capital N here?
72.
72.
72. So capital N shows the total number of items in the population. So in total we have 72 number of bananas. Now we are selecting a sample of 6. Okay. So this small size, which is the sample size, it is 6. Now this M, what will be the M here?
12.
12.
N will be, M will be 12. Okay. So
Yes,
we have
ma'am.
to find the expected value of X. So if you remember the formula, it is N into M divided by capital N. So just put the values. So
1.
N is 6, 12 divided by 72. So it will be 1. Okay, is this clear to everyone? Okay.
Yes, ma'am.
It should be number of rotted bananas selected. Okay. And then, okay, the next question, is this question clear to everyone?
Yes, ma'am.
Now we have
Yes,
our
ma'am.
last question. The average number of penalties charged by a police in a day for not following the traffic rule is 5. Assume that the number of penalties charged on different days are independent and follows a Poisson distribution. So find the probability that less than 4 penalties will be charged in a day. So we can consider a random variable x, which will represent the number of penalties So x here is following Poisson distribution. And what will be the value of parameter lambda here?
5.
5. Okay, because lambda represents the mean. So the average is given as 5. This is given as 5. We have to calculate probability of x is less than 4, right? Number of penalties charged is less than 4. So this is something we have to calculate. So here we just have to make use of the PMF of Poisson distribution. This is something we have to calculate. The PMF is e to the power minus lambda, lambda to the power x divided by x factorial. Okay. So probability x is less than 4, which means we have to add x is equals to 0, x equals to 1, then 2, and then x is equals to 3, right? Now just put the values in the PMF. So lambda is 5. So e to the power minus 5, 5 to the power 0 divided by 0 factorial, then e to the power minus 5, 5 to the power 1 divided by 1 factorial. Okay, is this clear? Okay, you just have to calculate this value. Calculate it.
Zero point 27.
0.27.
Okay, so it depends on how, in how many places you are taking it. So 0.24 or 27 something it will come. Okay. So the range you can check here. It's 0.22 to 32. Okay. It's coming in the range. Okay. Is it clear to everyone? If you take up to 3 places, it might be changing, and if you take up to 2 places, it will be a different value. So don't worry about that. That's why we gave the range. And here it is given that we have to take up to 2 decimal places. Okay. Anyone else has any doubt?
It's not something related. I just want to
Sorry.
know how likely we would get similar type of questions in the ET.
Yeah, sure. Similar type of questions you will get.
In the ET, is it? Okay.
Yes, it's in the income exam. Anything else?
No,
Okay, all the best for your exam.
Thank you so much.
and this is the last session.
Yeah, this is the last session.
Okay. Thank you.
Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Good night.